Welcome back, everybody. I'm Matt Rose, Field CISO at ReversingLabs, and this is Reversing Glass. The title of today's session is DNA of an application, and really going to just kind of set the stage here for what we're going to be talking about. A lot of people have been asking, supply chain risk, supply chain security, how does that map to application security and all the star AST tooling that I have for different aspects. And I figured this would be a good way to kind of explain how supply chain can be part of that application security ecosystem. So we have, a little box here representing my app, but apps are very complicated. There's a lot of different things happening in an app that actually allow it to run, function, and do all the things it's supposed to. So the first thing that we're really thinking about is the source code itself. So people, want to write an application, they got to write it in some sort of code. So Java or .NET or JavaScript or all these type of things. So there's source code within an application. Yeah, people probably already know this, but I'm just kind of setting the stage. The second thing that people really think about and are using a lot today are APIs. APIs allow you to leverage the functionality or data from a different application, or allow you to share your data from your application to another application, so on and so forth. And then we think about all the associated open source packages. Also, just say open source. So a lot of applications, people don't like to reinvent the wheel, so they use a ton of open source packages. The numbers that have tossed around by industry analysts can be, anywhere from 40 to 80%. Big swing, but it depends on what article you read. And then you're also thinking about all the other pieces of an application, maybe the application in a running state, in testing for vulnerabilities and issues within an application in a running state, post-compilation. And then, falling into all these areas too are, frameworks and libraries and all these type of things. What we're really thinking about now is the technologies that address each of these areas. So source code is an application security technology, SAS, static application security testing. Testing the source code prior to compilation, looking for vulnerabilities like OWASP top 10, so on and so forth. And then we have API security that basically allows you to look at the usage of APIs. Is it authenticated correctly? Is it sharing data correctly? And this is another big area that people are really focusing on. In open source packages, this is where software composition analysis comes into play, where you're actually scanning the open source packages for vulnerabilities, for licensing issues, for inheritance of packages that may be insecure, so on and so forth. And then the last one, and again, this is not a huge comprehensive list, it's kind of just explaining things a little bit. This is where running application is either done through consulting, through pen testing, or dynamic application security testing. Now here's where we're going to kind of transition into how supply chain security or supply chain risk comes into this. So you're doing all these things, but they're all looking at a certain aspect of an application. SAS is looking at the source code. API security scanners are looking at the APIs. Software composition analysis is looking at the open source code. DAST is looking at the running application. But what are you doing for malware? It's not typically one of the functionalities or capabilities of these products to look for malware. This is where supply chain security comes in. A lot of times people talk about supply chain security about, scanning and understanding the software bill of materials for a third party or a commercial application, but it also has the capabilities to potentially have malware in your homegrown apps just by the complex development processes. As I mentioned, a big topic these days is the SBOM, or the software bill of materials. Software bill of materials is listing everything in the application, and some of the technologies that I mentioned on the right for different aspects of the application do include an SBOM, but it's a limited SBOM. Like open source analysis provides a software bill of materials, but it's typically around the open source packages, so on and so forth. And one of the biggest things that I am very passionate about is these things are all looking at a piece. They're all looking for a certain pattern. The secret sauce behind SAST or DAST or API security are rules or checkers or queries, but they're looking for a certain pattern of risk, like SQL injection, cross-site scripting, cross-site request forgery, those type of things. But within supply chain security, looking and understanding all the files that are part of your package. So you're thinking about every file. Is there some files that shouldn't be in there? Is there a type of file that you didn't know was in there? And this is where these kind of areas here that I'm highlighting right in this big box here is software supply chain for application security. To be able to find, is there malware in my application? A complete SBOM of the entire application package, all the files and any issues within the files, or CVEs or things like that. So when you think about a DNA for an application, we're doing a great job at the components or risks or vulnerabilities found by the kind of standard application security scanning technologies. But the supply chain risk is basically still not there. You're not actually finding it with the tooling that you already have. And this is where I believe that supply chain security is something that should be part of any robust application security program. I'm Matt Rose. This is Reversing Glass. Thanks for watching, and stay secure, supply chain world.